Stat is there. It is not
Stats is
ended.
going on.
So
Okay.
it it will be in within 5 minutes. So
Okay. So today we are going to discuss week 5 solve with us. Okay, and then today would be the last session for week 5, and coming 2 sessions will be revising and we'll be solving the problems only. Mostly that will help you for the quiz. So quiz syllabus, I guess you might be knowing that is from week 1 to 5.
the 4, right? So
Sorry, week 1 to 4. Sorry.
Sir, how many questions will be asked for the exam? Total number of questions.
Altogether, it will be some 15 questions. 15, 14, 15. Like you can just think of as some 15, 16 questions. Yeah, of 50 marks.
Questions per subject.
Yeah, per subject I'm talking. Yeah.
Yeah, okay.
I don't know about the stats, but maths I'm just talking about. So mathematics will be having some 14, 15 questions. Yeah. If you have any doubt regarding the question paper, not question paper, I guess the quiz, you can just ask. We'll start in by 8, 10, 10 or 8:15. By then, I guess stats.
The time
Ah.
is 4 hours for all subject or 1 hour for each.
No, it will be all together 3 or 4 hours, whatever the number of subject you have.
Yes, sir.
It will not be bifurcated subject wise. Overall, it will be 3 hours or 4 hours. It depends on how many
Okay, sir. Thank
you're
you.
writing. Yeah. So if you're able to finish one subject early, you can just give your time to the other course. Maths, it might take time. Like you will be able to solve it in 50 minutes or 55 minutes. So the paper that has been given for the quiz, right? It will be. You should be revising the polynomial very nicely. Week 1 also, the all the types of relations you should be knowing very thoroughly. You already might be knowing. So these are the topics from where every term some questions will be there, like the type of relations. Okay, whether it's a reflexive, some functions or some relation, some sort of relations will be given to you. You'll have to check whether first of all it's a relation or not. If it's a relation, which type of relation is it? Okay, symmetric, reflexive, okay, equivalence relation. So you'll have to check that. Okay, so those type of questions you'll have to practice thoroughly. So we'll be having some 2-3 sessions. 2 sessions we'll be having in the coming week. There you can ask the doubt, even though we'll be solving some problem from those topics. Okay. Yeah, mock will be released by tomorrow.
so will it be very tough? Will it take
No, no.
consume more time?
No, it will not be tough. I already told you, right? It will not be tough. It will take some 50 minutes, maybe 40 to 45 minutes if you have thoroughly revised it. It will not take more than that. So whatever the topics that I'm telling you, you can just revise it nicely. The types of relation that you should be knowing. You can't just skip that portion for sure. Okay, and then the Venn diagram questions that you should be knowing how to solve those type of problems. Okay, from week 2 you should be knowing the SSC concept. Okay, so squared error. If you're not knowing, then go and revise it, solve some problem, come in the doubt session and ask. Like you'll be having some 2 sessions, right, for the doubt. So you can just ask your doubt in those sessions. SSC is the most important portion for week 2. Even though the other parts are there, you should be knowing what is the relation if the two lines are perpendicular to each other, parallel to each other, section formula, all those things you should be knowing. Those are very basic stuff you must be knowing. Angle between two lines and all the formulas, slopes, concept and all. But the most important portion is the sum square error.
Excuse me, sir.
Every time you will be getting some questions from those portions. Okay, so you should be knowing that portion.
Excuse
Yeah,
me.
yeah.
Sir, I could join a little late, so could we still the important things just you told the advice?
Yeah, what I was saying, from week 1, everything you have to revise, but the most important portion that you can't skip it is the type of relations. Okay, how to check the given relation, whatever
Type of relation.
the relation has been given, is whether first to check whether it's a valid relation or not. If it's a relation, which type of relation is this? If it's a relation, then what are the conditions that this relation will be a function? Okay, so this 3-4 things that I told you must be knowing. Okay, you'll be given, and most of the, like, you'll be having some 40 to 50% of the paper in MCQ plus NET, and then 50% of the paper will be numerical answer type. Okay, so from the relations and all, mostly you'll be getting MSQ. Okay, so multiple select question options. Okay,
Means
so
50%
might
of
be,
the paper will be numerical attempt.
yeah.
Okay.
Okay, and
The
then
important
week
thing
2,
about this type of relation, it is at all a relation or not, then which relation is be a function.
those type of things I hope it has already been taught,
Yes,
so
and
you might be
that is
knowing.
from week 1 and week 2, week 3, other weeks could you please suggest?
Week 1 I was talking about the Venn diagram also might be.
Okay.
Please revise it. At least solve some problem from the Venn diagram also. At least a graded practice you should have solved at least twice. Okay.
Yes, okay.
Then the second week I was saying all the basics formula. Okay, the condition of parallelogram, perpendicular, all those things. The most important portion is the sum up squared error. Sum up squared, if you'll see, every term there will be a question. Okay, so you should be knowing how to calculate the sum up squared error thing.
Sir, what parallelogram you were saying? Parallelogram, nothing was mentioned.
No, not parallelogram. I was talking about the condition for the two parallel lines,
Oh,
two
okay.
perpendicular lines. Okay, if you have been given what is the any of the questions will be asked like the slope. If a line parallel to x-axis, what the slope? If a line parallel to y-axis, whether the slope is 0, 1, infinite, or not defined. Okay,
Okay.
those are things you might be knowing. Very, very basic things. And then week 3 is you should be knowing how to this quadratic equation if you have been given whether this is going upward, downward, parabola. If you are able to show it in a like a graph, so there might be 4 graph will be given with the equation. Okay, and then you'll have to check whether this pass like the number of equations will be 2 or 1 or to touch x-axis. So these are things you must be knowing. Okay, I hope I have has already been taught in one of the classes, right, about the quadratic equation.
Okay.
And then from the polynomial, you must be knowing how to plot the polynomial first of all. Okay, what's the number of turning point? If you have been given the polynomial, 2-3 different polynomial, if you have been asked regarding the summation of all those polynomials, and then check whether if the x tends to infinite, how does the functions will tend, whether it will tend to infinite, negative of infinite, those types of things you must be knowing. Okay,
Is the end behavior of the polynomial.
in the behavior. Okay, those several things you should be knowing. Okay.
Sir, one question means the 1 week only left for the exam, and we have to also submit the graded assignment of week 5, and so we have to studying that also. So could you please advise how to manage between this means week 5 content and revision of other full weeks in this week? Full will 1-4 plus week 5 also studying.
Week 5 today. Today you just finished week 5. Just I hope you would have gone through the lectures also. So today you solved the problems from week 5. And then the remaining 6 or 7 days that you have, right? You just keep for the revision of week 1 to 4. Even though we'll be revising in 2 of the sessions, the coming
So all
session, the
subjects
Tuesday
I could
session.
not go through the lectures actually. Means maths have gone and some stat I've seen, but
Okay, so see, what you can do maximum is see there. If you would have gone through the grading policy, right? You can, if you are having a like you are maybe if you have a lot of work and you have a dual degree you're doing, right? You're not getting time, and because this would be a qualifier exam, that is the most important, right? You should be taking, and first of all, you have to pass the qualifier exam, right? And then only you can think of a good score in that subject, right? If you're not able to qualify, then there is no point of submitting week 5, 6, 7, right? So
yes, but there is the deadline. So how to manage the study?
no, that I can understand. But week 5, see, if you would have submitted week 1 to 4 nicely, even though you're not submitting one of the weeks, right? That is not going to hamper your score overall. Because if you see the grading policy, right? I hope you would not have gone through that. There is a, if you're not able to submit one assignment, okay, that is fine. Like your marks will not get hampered very drastically, even though we are just considering 10% of the graded assignment score. Okay, and that too, not all graded assignments, some best 7 or 8 out of 11. Okay, so that you have to check in the grading policy. So what I'm trying to say is, if somebody is writing the qualifier exam to take the admission, okay, if you have not gone through week 5 till now, okay, you just, as of now, you can just hold it and then revise at least week 1 to 4 nicely all the subjects, so that you can at least qualify the exam. And then after the qualifier exam, you don't wait for anything, you just go through week 5 6, right? In the next, like after the qualifier exam, that whole week you just give it to the week 5 6 and try to finish it off. Because if you'll just give it more time for week 5 in the coming week, that is not going to help in the qualifier exam. That is what I'm trying to say.
Means,
If somebody has already taken the admission, I would suggest you to focus on week 5 also. Like, for example, who has directly came through the JEE, you can just go through the week 5 also, give it more time for week 5 also in the coming 1-2 days, and then you can last 3-4 days, you can give it for the revision. But who is writing the qualifier, I would suggest you to revise the whole thoroughly, week 1 to 4, attend all the live session, and the last 2 live session, that will be for the revision. That will be the utmost, so you'll have to attend that. You can't just skip those. That's the most important. That will give you an idea about how to solve like which type of problems will be asked in the paper. Maybe that can give you an idea also. We'll be going through the concepts also, but we'll try to solve some problem that will give you a gist of idea about which type of
That means
problems
if
will be
I
asked.
just for once don't submit this week's week 5 assignment, will there be very much drastic hampering in the grade?
There won't be any drastic like changes in your score. Yeah, but you do not have to skip more. You can skip max of 1. Okay.
Okay.
Yeah. Okay. Yeah. So we'll just start it off. Just give me a minute.
Today we are going to focus on week 5, Vishal.
Yeah. We'll solve problems from week 5.
Okay. And I have
Yeah.
a
Today will be
like,
the last session for week 5, and after that.
Okay.
After that, from Tuesday session, we'll be we'll be revising week 1 and 2, and we'll be solving problems from those like weeks. And then one more session we'll be having, that mostly will be on Thursday or Friday. I'll have to check that. There we'll be solving the last 2. But whatever question that we'll be solving, that will be the most. We'll not be going through any topic that is not going to help you in the paper. Okay. So yeah.
when will we have the mock
excuse me,
for
sir.
max
For the
Mock
coming
will be
session,
released tomorrow. Yeah.
tomorrow? Is it? And the deadline, I think, because today we got for stat, I think it's just the previous day of the exam. Am I right?
What?
Today there was an intimation for the stat, and it's the previous day of exam. So for the mock of statistics, which is on 11th, they said at 8 p.m. And you say max you'll release tomorrow, and
Yeah.
the deadline for that will be again on 11th, or
No, that will be by Friday. So you can just submit it before one day, like 10th or 11th, you can submit it before 11th. I'll just keep one session for discussing the mock also. So I'll give you the deadline by 11th, so that 12th on the last day, we can discuss that. Or maybe in the last revision session, we can discuss that. So I'll release it tomorrow, and then the deadline also you'll get to know tomorrow itself. I'll give you some 3-4 days to submit it.
Oh, that will be wonderful. Okay.
Sir, actually,
Because
I have passed the JEE Advance also, but even it is showing that I log in through qualifier.
You have already got the admission through JEE, right? Then this exam for you will not be a qualifier, but the
Like
quiz
it is
paper.
showing that I joined like not through JEE, but with qualifier only just. I mean
Then you
qualifier.
have to, then you have to write this, right? And then pass it also. Just give me a second. Yeah.
We cannot edit, sir.
Give me a second.
Sai, with regard to what you're asking, I think you should write to the support team for if you have any issues that qualify a case.
Sir, to which one? Support team means which?
Yeah.
Main.
DS support at IIT. And I think now it's too late also that you can change anything, if I'm right. Am I right, Vishal?
Yeah, it's too late now
Too late
because
now.
like the exam now they will release the hall ticket itself. You should have asked in the first or second week itself.
Like I asked her, but no reply I got, so that's why I left it, sir. But now again I'm asking because exam has come now.
Okay, so did you ask the instructor whoever was taking the session?
Yes, sir. To the maths, ma'am, I have asked her.
Okay. Okay, but now okay, you just first write the exam, okay, and then we'll see what can be done. Huh? Because in any
Okay.
case, if you have to write the exam, right? If you qualify, then it is same, right? You come through
Yes, sir.
JEE or qualify. Yeah.
Yes, sir.
Yeah.
Okay, sir.
Sir,
Like
Yeah,
just
you
a
don't.
sir, I
there
have
is
a doubt.
we have no option to edit, sir. Now.
No, it's too
Now
late.
I don't think so. You have.
It's too late. Maybe as Vishal was suggesting, you write the exam, it will be kind of experience for you. But if you already have qualified, maybe this score you can directly continue. I think this won't have any impact on your this thing qualification or something, qualifier or something. If you are already qualified through JEE.
Okay,
But
sir.
don't skip the exam. Don't take the risk.
Okay, sir. Thank you, sir.
Sir, I have a request. Like, why do we actually have this week 5 or week 6 release before this quiz one? Because it's kind of creating a lot of ambiguity among everyone. Not only that, see, this batch I could see for everyone
No,
so much
no.
of
So
ambiguity. But
this, yeah. So because of the paradox that happened last month.
yeah.
So the term started beforehand itself. We can't put like if you would have gone by that schedule, the first the quiz would have happened 15 days before itself. But
Yeah.
I don't think so. That was a good idea. So that's why we have extended for 15 days. But we can't extend the week 5 and 6. Even though we were having the choice to ask week 5 also, but we have gone with week 1 to 4 because that would have been a burden for the student. So that's why we are going with the week 1 to 4. Even though for the some of the courses, it's going with they're going with week 1 to 5 also, but we are just sticking with week 1 to 4. And see,
I
it will
think
be
all
too
the
late because
two
quiz 2
English,
again
two
you'll be
maths, everything
having
is week.
after 20 or 25 days itself. So again, that would have been difficult for you guys also and for us also to conduct all the live sessions after the quiz paper. So that's why we are just sticking with week 5 to be done, and then week 6 from will starting. Even though week 6 content is also released, but we'll do the sessions and everything after. After the quiz paper.
Quiz. And I think for quiz 2, we don't have sufficient time. We have only 20 days to go for quiz 2.
Correct. Yeah, because all these things has happened. Because we have some events and all, and because of that, this quiz 1 got delayed. But otherwise, week 2, week 3, everything will be on time.
Yeah, and you are right. I think for this semester they made for all the English 2, math 2, everything is up to week 5 because they sent an email yesterday for this.
Yeah.
Only for
But
all the ones. See that.
Correct. Yeah. So shall we start now? If you have been already taken all your doubts, yeah. Yeah, Vilasa, we can just
Just a minute. Sir, actually, like this session is like a revision session for the qualifier exam, or you can say quiz 1 who have qualified, right?
Yeah, this session is mostly for those people who will be able to get. But even though, if like, I hope here also things like one function will be dealt with, right? So those can be asked in week 1 also. Week 1 also you have this stuff like to regarding the functions, right? So that has been taught in week 1 also. So if you are attending, that will be good only. And yeah, if you are like have to revise it week 1 to 4 itself, even though you have to submit week 5, right? Because you'll not be getting any other opportunity to submit week 5 again, because the deadline is on to 9th or 8th, I guess.
Yes, sir. Sir, and the syllabus is for syllabus for the exam is from week 1 to 4,
Yeah,
right?
syllabus is week 1 to 4 itself. Yeah.
Okay, sir. Thank you, sir.
Sorry, Vishal, what's your plan today?
I will be discussing week 5 questions.
Only week 5. Okay.
Yeah. Week 1 to 4 will be revising in the coming Tuesday, and then one more session will be happening.
Okay. Because I thought just the previous conversation we were discussing, I thought you were actually going to mix 5 and 1 to 4 also today. So that's why I want to
No,
clarify.
week 5 only, and week 1 to 4. Even though I have just told you like the important topics that everyone should be knowing from week 1 to 4 in the starting 10-15 minutes. But I'll go through that again. We'll discuss some of the problems from week 1 to 4 in the coming week. But
Okay.
yeah.
Thank
Okay,
you.
Avilasa. Yeah, thanks. We can start it off. Yeah, you can share your screen and then you can start. Over to you, Avilasa.
Thank you, sir. So hello guys, hello everyone. I'm one of the course instructors for Math 1 this session, and for today we'll be discussing questions from week 5. So I'll just share my screen. Yeah, hope it's visible to all.
It's visible, ma'am.
And
Yes, ma'am.
okay, and if there are any doubts while we're discussing the questions or after the questions, you can put them in the chat box,
And
or
could
you
you
can
increase
just
the
raise
font
your
size?
hand. Yep, sure. I'll just increase the font size.
Can you increase the font size, ma'am?
Just put the doubts in the chat box or just raise your hands if there are any, so that doesn't interrupt the flow of the session. Okay, let's just start. So here's this question. The first question is this. And before we start off with the question, I'd want you to give it a try. So try solving it and then
And please
do
increase
it.
the font size. It is not clearly.
We're not doing anything right now. I want you to try the question first.
No, ma'am. Could you please zoom?
I'll
zoom?
just. Okay, sure.
Thank
Is
you.
this all right? Okay. Just drop the answers in the chat box once you're done. Okay, that was quick. So we'll just solve it anyway. I think everyone's able to do it, but let's just do it anyway. So this is the question, and you've been given that your 2p is equal to q, and you've been asked to evaluate this value, 4p by 2q plus 25q 625 to the power p. So let's just write this as 2 square to the power p by 2 to the power q plus 5 squared and then to the power q. No, let's just not this. Let's just change the 625. Let's change this instead. As a the other key. Gives us which is, I hope my handwriting is legible. And this. And from this equation right here, we have 2p minus q equals 0, which gives us 2 to the power 0 plus 2 to the power 0. So yeah, this is the answer. And whoever's got this answer has got the answer correct. So I hope you guys don't need time to just review this answer. It was like an easy question. So we can just move on. We can move on to the next one, right?
Yes, ma'am.
Ma'am, can you show the question again?
Yep, sure. The first one, right? Yeah.
Okay, ma'am.
Can we move on to the next one?
Yes, ma'am.
Okay. So up next we have this question. And I want you to give this a try and put your answers in the chat box once you're done.
Hello, ma'am.
Yes.
Ma'am, it's a dot class, ma'am.
It's a question discussion class.
Week 5.
Yep.
So I can ask my dot.
Yep, you can ask your doubts once we're done with the questions that I have.
Okay,
I'll
ma'am.
take the doubts after that.
Okay.
Okay. So I think that's enough time. We'll start doing the question now. So we've been given the definition of what a half-life of an element is in the beginning, and then we've been given an equation, which is AT equals A naught half to the power T by gamma. where gamma is defined to be the half-life of the material, which is defined in the beginning.
Ma'am, I have a doubt.
Yes.
In the previous question, the RHS of the equation are like how did you change that q minus 2p to 2p minus q? That is what I want to ask.
Okay.
Like that is
Yeah. This is 2p minus q here, which is 0. And if you just put a negative sign on both sides of this equation,
no.
we get.
Okay. Yeah.
Is that clear now?
No, actually.
Okay. What's your doubt?
Like then that one, you can go on. Like you were explaining something.
Sorry.
Sorry for yeah.
Are we clear with this question? Can we go to the next one? Okay, we're proceeding with the second question. So this is the equation given to you. And your gamma is given to be the half-life, which is defined in the beginning of the question. And A naught is the initial concentration, which is this, actually, when your T is 0. And AT is the concentration of the radioactive element in the sample for time T. So AT is defined here. And then if they're given the other information, if radium has a half-life of 1600 years. So we know that the half-life is gamma here and it's given to be 1600. And the initial concentration of radium in a sample was 100%. So we'll just assume the initial concentration is A naught, right? So let's just say that this is 100%. So we're denoting the 100% as A naught. And then we'll find something in terms of A naught, and then we'll find the percentage of that with respect to this A naught. You just know what I'm saying in a while. And the initial concentration of radium in a sample was 100%. We calculate the percentage of radium in that sample after 2000 years. So your T is.
Excuse me, ma'am.
Yes.
I mean, this question in the first part, it is once mentioned that AT is the rate of change, but in the second part, it is mentioned that AT is just the concentration at time t, but both things are different. Means at the first part, AT is the rate of change and means concentration by time, and in the second part, AT is the concentration itself. So both things cannot be same. There is a misprint, I think.
Yeah, it's actually the concentration of radioactive element in the sample after time t. So it's this one.
Is after time t, but it in the second part, AT is the concentration it is given at any particular time, but in the first part, it is given the rate of change of concentration. Both are the different things.
So
So
that must be a misprint then.
yes, sir.
It's corrected. Okay, thanks. So we'll just have to plug in these values in the equation. So we'll plug in 2000 here. We'll get A naught half to the power 2000.
Actually, I was going by the first part, so I tried to integrate it, and then it became complex.
Yeah, that's all right. I mean, now you know that it's the second one. The definition is this one, for AT. You don't have to do the integration and all. Okay, so this is it, and this is A naught half to the power 5/4. So this is your concentration at the time T equals this. And we need to find the percentage of radium in that sample after 2000 years. So initially it was, let's just say initially it was A naught. And now it's A naught half to the power 5/4. And to calculate percentage, we multiply by 100. So we get 100 half to the power 5 by 4. Is that okay? I'm assuming everyone's clear with this.
Ma'am, at the last chapter.
Can you please explain the
Yeah.
question second?
Ma'am, is this
Yeah.
the final answer?
Just one by
100.
one. Can you just raise your hands and then, or you can just go one by one.
Ma'am, is that the final answer? We don't have to solve any further.
I mean, you'd need to wait.
Ma'am, can you
I mean,
please
you'd need a
explain this
calculator
one?
to solve this further. You can't just solve it manually. You can just go
Ma'am,
on
can you
and
please explain this
calculate the
once?
approximate. Yeah, which part? Someone had a doubt. Which
Ma'am,
part
at
do
the
you
last
want me to explain?
Ma'am, at the last step, you have took
Ma'am,
the
from
ratio, right?
A of 2000.
Yeah, we need the percentage. So the initially it was A naught.
Okay.
We need to find the
Ma'am,
percentage of
how you
this.
write A naught is equals to A of 0 in the second line? From
Yeah,
starting in the
right?
second line.
Yeah,
Yes,
right. So it's
yes, ma'am.
A naught is defined to be that only. A naught is defined to be the initial concentration, which means your concentration when your time is 0, right? That's what A. Or you can just see it from here. See, you can put a 0 here on both sides of the equation. You get A naught
At
only.
initial, we take time is equals to 0.
Sorry.
At initial stage, we take time is equals to 0.
Yep, you do, and you can just check it from here. You can plug in t equals to 0 on both sides of the equation. This gives you this. Can we proceed?
Yes, ma'am.
Okay.
Excuse
So
me,
here,
ma'am. Ma'am, how to
yes.
use a calculator to solve the above problem? Because this on-screen calculator is little new to us. Can you guide us on how to use the calculator to solve this?
Are you allowed to use calculators in the exam?
Ma'am, on-screen
Yes,
calculator?
ma'am.
Yeah, on-screen calculator is allowed, I think.
Okay. So I don't think you need I don't have that on-screen calculator right now. You can just do the usual.
Ma'am, in the examination, on-screen calculator is provided.
Okay.
I mean,
So
ma'am, I do not know how to reach, like some people have answered as 42. I do not know how to reach 42 with this answer.
okay, you just as you use the normal calculator, I believe your online calculator is the same. It's not some scientific calculator. So you can just put it there. Just put it in the calculator, 100 multiplied half to the power 5 by 4. Hello, is that clear?
Yes, ma'am, that's what I'm
On most
asking.
calculators, there's this sign. There's this symbol on most calculators to raise it to the power.
Okay, ma'am, then I'll try.
Okay. If you still are not able to figure it out, I can just let you know in the next class. Is that all?
Okay,
Can
ma'am.
we move? Okay. Can we move on to the next question? Okay. Just give this question a try and then we'll do it.
Ma'am, is this is an incomplete question as it was written two functions fx is equals to this and the other part is seems like it is missing the other function.
No, this is the other part. This is f function, this is g function, and you're supposed to find the domain of the composition of these two functions. I mean, it's a
Okay, ma'am.
little messed up, I know. This has to be after this one, well defined.
Real number it is.
Okay, just you don't have to unmute, just put it in the chat box. Put your answers in the chat box.
Now option number 1.
Just put your answers in the chat box. And this is a multiple select question, so there can be more than one answers to it. I think that's enough time. You start doing the question now. Okay, so your fx is given to be x plus 1 to the power half, which is the same as this. And your gx is given to be x square minus 1. So when we compose these two functions, GOF, right, we get x squared plus 1 square root minus 1. We've just used f as an argument here. Instead of x, we've used f as the argument. And so we
It
get
will be
this.
square root of x squared plus
Yep,
1 whole
yep.
square.
It's square. So this is your composition. And this is not equal to x on R. So on whole R, this is not x, though this function GOF of x is equal to x for x greater than equals to 0. In fact, this is not even defined on the whole of R. So,
Excuse me, ma'am.
Why?
Can you explain that x squared plus 1? From where did that come? Squared plus 1 in
which
the
one?
composition of GOF. X squared plus 1 inside the year. That one.
Yeah.
Yeah.
Oh, that's a mistake. Sorry. Thanks for correcting it. This is it. It's still not x.
Ma'am,
Yeah.
why GOF is not defined on R?
Sorry.
Ma'am, why GOF is when GOF isn't equals to X on R, why this is?
Okay, so first thing is when we say that GOF of x, it's x here, G of fx is not equal to x on R, we mean that for all, it might be true for some values on the real line, but it's not true for all values on the real line. Right? So this is not true for all values on the real line, and that's why we say that this is not true on the whole of R. And we'll, okay. And then we'll just see so let's just see where it's defined before like moving on to anything else. Let's just see where your GOF is defined, where this function is defined, right? So we'll just take something less than -1. Let's just say we take something less than -1 here, right? So we'll take something less than -1, this square root, where x is less than -1, your x plus 1 will be less than 0. And then your root of x plus 1 is not defined. Not defined. So to avoid this, we'd want that our x is greater than -1, or at least it's actually greater than equals to -1. So we'd want our x to be greater than equal to -1. That's where your GOF is defined. And if you look at this function, we need to find the domain of this function. And the domain of a function is where a function is defined. That's the natural domain of the function, right? So since this function, because this function is defined for everything greater than -1, for every value of x greater than -1, that is why this function's domain is from -1 to infinity. All right. So to get into the more detail of it, we'll try another way to see how this is done, right? So usually when we try to see the definition of domain of GOF, how do we define the domain of GOF? We define it as x such that your x is in the domain of F, and it's intersected with x such that your fx is in the domain of G. So what you want is, for this function GOF to be defined, you want f first to be defined on x. That's why you want x to be in the domain of f, and then you want g to be defined on f of x here. This is nothing but g of f of x. So you want f to be defined on x, and then you want g to be defined on fx. So this is your domain of GOF. We'll first try to find out let's just find out the domain of f first. The domain of f is, our f was square root of x plus 1. So its domain is -1 to infinity, right? Because if we put anything, we've just discussed this, if we put anything less than -1, so your x plus 1 becomes negative here. And the square root of something negative is not defined. That is why your domain of f is from -1 to infinity. And then we'll see this set. This is x, where fx belongs to the domain of G. Let's just try to find out all of it.
Ma'am, what is the final answer of question 3?
We're getting to that in a while, if you'd wait.
And could you please scroll up a little?
Sorry. So we need to find this, and the domain of G is, so your G is x squared minus 1. We need to find the domain of this, and the domain of this is whole of R, because x squared minus 1 is defined everywhere. And then we need to find x such that fx is in the domain of G. All right. So we just need to find whether fx is defined. Because if fx is defined, then it's a real number. And if it's a real number, then it's definitely in the set of real numbers. So we just need to find whether fx is defined, which is again the domain of F. So this set is actually -1 to infinity only. Because we need to find x such that fx is in the domain of G. The domain of G is whole of R, the whole real line. So we just need to find x such that fx is defined. Because when f is defined, its value lies in the real line only. So this set is nothing but the set, let's just call it A set. This A set is nothing but this set. And initially, we were supposed to find the value of the intersection here. This value is what we're looking for. So this, and then intersected with this, which is nothing but -1 infinity. This is the intersection of both of these intervals, is this. And then this is one option that's there, this one. And then let's just check the other option. So R cannot be the correct option because R is not the same as -1 to infinity. So this is not the same as this, and the domain is this. So this is definitely not the right choice. This is not the right choice because, okay, I hope you're able to see that this is not the right choice. And we can discuss this if you can't. Let's just look at this option now. It's -3 to infinity minus -3, 5 intersection -5 -1. This is it. Let's just have a quick look at what this turns out to be. This is the real line. Let this be 0, -3, 5, -1. Yeah. This is the interval -3 to infinity. Actually, the open interval. This, and then extended to infinity. And then we have -3 to -5, which is this interval, intersected with -5 to -1, which is this interval, this one, this one, this one, and the intersection is this, -3 to -1. This is 1, -1. And then we just need to remove this interval from -3 to infinity. So -3 to infinity is this, everything after -3, and this is -3 to -1, which gives us -1 to infinity. So this whole thing is actually equal to this thing. That's why that's also the correct option. I hope that's clear.
And
This
could you please
is
explain how option 2 is correct? Again, I couldn't get it. Option 2.
this option's correct because this set is the same as this set. Just
Yes, means
explain.
how did it become similar to that?
Okay. This is -3, and it extends till infinity. This is this set. All right. And then this is -3 to 5. So we need to subtract the intersection of these two, not subtract exactly. We need to remove the intersection of these two sets from this set, right? Let's just find out the intersection of these two sets. This is -3 to 5, this set. And this is -5 to -1, which is this set. And when you take the intersection, it's this, right? The interval that lies in both of these intervals is this one, -3 to -1.
Ma'am,
And
when we take the section of -3, 5 and -5, -1, what we will get?
we'll get -3, -1. This open interval is what we'll get. Just look at it. Look at this, no? This is the whole interval, -3 to 5. And this is the whole interval, -3 to -1.
Excuse me, ma'am.
-5 to -1. Yes.
I'm sorry, ma'am. Means A difference set A difference set B means you have to remove A from B or B from A. That
This means you have to remove this set, this whole set,
okay.
from this set.
Okay.
Is this clear now?
No, means okay. The intersection part I could understand, but how the whole set is becoming equal to -1 infinity, that I cannot get it.
Okay, this is the set -3 to infinity, right?
Yes.
It just keeps extended, never ends.
Yes.
And then the intersection is -3 to -1, right?
-5 to -1. Yes.
Let's just, did you get it or should I explain?
The intersection part I understood, but after
Okay,
that I
this
couldn't.
is -3 to infinity, and you need to subtract -3 to -1.
Yes.
Note that these 2 points are not included in the interval -3 to -1.
Oh, okay, okay.
Okay. So when you will exclude it from this whole line, this would be included here.
Okay.
So you get -1 included to infinity. Is that okay with everyone?
Understood.
Okay. Do we need time to analyze this, to have a look at this, or can we move on to the next question?
Just 1 minute. Little bit.
Ma'am, can you explain this question?
Which part did you not get? Which part do you want me to explain?
This question.
The whole question?
Yeah.
Okay. There are like 2 ways to it. First is this one, it ends here. This one's like this ends here, you don't have to do much. And then you can just do it this way by the proper definition of how you define the domain of compositions. So you've been given a function g. I mean, I need to know which part did you not get. Because it's a long thing that I've explained. Did you not get anything at all?
Okay.
Do you want me to repeat the whole question, the whole solution, or some specific part to it? I'd appreciate a prompt response, please.
Yeah, ma'am. Yeah. This question explain this.
Okay, I'll just explain the whole question one more time.
Okay.
And so when you define the domain of GOF, this is how it's defined. And I've explained why this is defined in this manner. So it's basically the domain of F, and we take the intersection of this set with the set where the collection of X, where Fx is in the domain of G. I hope it's clear that why this set is equal to this set. So the domain of F we've already calculated, it's -1 to infinity. If you just, and I've explained here why it's -1 to infinity here. Because your X, for this to be defined, this is your Fx. For this to be defined, when we say X is in the domain of F, we mean that we want the function to be defined on it.
Okay.
By defined, we want it to have real value at that point. We want it to have a value and have a unique value at that point, right? So that's, you need to find the domain of this. So you want this function to be defined. So you want this, we know that square root is only defined when the argument is non-negative. We want the argument to be non-negative, right? So
Yeah.
if this is the argument, if this turns to be less than 0, then this is not defined. Then your root x plus 1 is not defined, right?
Yeah.
So you would want your x to be greater than equals to minus 1. But avoiding the values where x is less than minus 1, because that's where a function is not defined. This is not defined there. You'll get something, let's just say if you take minus 2 here, you'll get minus 2 plus 1, minus 1. And this is not defined on real line, right?
Okay.
We don't want that to happen. That's how you get the domain of f equals minus 1 to infinity. And afterwards, we want to find the set. We want to find this set, right? Because we need the intersection there of this set and the domain of f. We want the intersection of these two sets. These two sets, we've already calculated the first set. We're on to the next set. A is equals to this set, right? So this set is C. You want x such that fx is in domain of G, right? And your domain of G is R. Why? Because your G is nothing but x square plus x square minus 1. And x square minus 1 is defined everywhere.
Yeah.
So polynomials are defined everywhere. This is a polynomial. You must have studied this. Polynomials are defined everywhere. So this is defined on whole of R. So the domain is whole of R. Domain of polynomials is the whole of R, right?
Yeah.
So you just need x such that fx is in R. Domain of G means fx is in R. So fx would obviously be in R because the codomain or the range of the function is always in real. We're studying real valued functions, right? Real valued means if you plug in something in the function, you get a real value. So the value is obviously real, right? So you just need to find where your function is defined. That's all. So where the function is defined, your fx would obviously be in R because it's a real valued function. And we've already seen where fx is defined. We've seen it here, right?
Yeah.
This gives us minus 1 to infinity. So A set is minus 1 to infinity. The previous set was also minus 1 to infinity, and the intersection turns out to be minus 1 to infinity. Is that fine? Can we move on to the next? Do you want?
It means basically you have to follow the domain of the inside function, intersection of the domain of the outside function.
No, it's not this is not the domain of the outside function. This is the collection of x such that your fx is in the domain of. There's a huge difference between the domain of G and this. This is not the domain of G. This is the collection of x such that fx is in the domain of G. They're not the same sets. They're different. And this is like a major mistake that people make. So please try avoiding it. This is not the domain. This is not equal to the domain of G. Different from it.
I'm sorry, the option 2 I understood, but finally, how are we getting minus 1 to infinity? The process, not only this sum, the process of finding domain of GF. Could you please?
Okay, you want me to explain this thing, right?
Yes, means the procedure, even if we don't go by the formula as you said, but the
Okay.
process.
You just explain the process. Wait. Domain of FOG is, first of all, FOG is f, nothing but f of g of x, right? And by domain, we want this function to be defined, which means we want it to have real values, right? So,
GX,
firstly,
could you please repeat?
okay, there's nothing to repeat. This is it. This is what I've said. That's all.
Okay.
This is the same thing, right? And we need to find the domain of this thing. The domain is what you can plug in here, such that this doesn't turn out to be something not defined. That's what we want. We want our function to be defined, right? So and it goes from here to here. So first you apply G and then you apply F in the composition, right? I hope this is very basic. You should know it already. You must have done it in your lectures. So if you need to find the domain of this thing, firstly you would want domain means you want this function to be defined at X. That's what domain means. So you want G to be defined at X first, because first you're going to apply this thing. So you want to be able to apply G to X, right? So you want domain of G, and in our questions it's GOF. It's not FOG. We're doing FOG here. When I question it's GOF. Don't confuse with that. So firstly, you want it to be defined here. So your G is to be defined at X, which means your X has to be in the domain of G. So for X to be in the domain of F of G of X, your X has to be in the domain of G.
Okay.
So you can say that your domain of F or G is a subset of domain of G. Right? Not every function, not every value at which G is defined is in the domain of F or G. Please mind it. That's why we take the intersection. So we need further conditions as well. This condition is not enough for X to be in the domain of F or G. So you need G, you need G to be defined at X. That's why you want X to be in the domain of G. And then you need, and now this is the argument, right? So this has turned into the argument of F. So you want Gx to be, sorry. You want Gx to be in the domain of F, right? So these are the two conditions that you want X to follow. You want these two conditions in X. For X to be in the domain of G, so let's just remove all of it from here. So if you want X to be in the domain of F or G, you want this to happen, this thing to happen. You want X in the domain of G and Gx in the domain of F. And that's how we've taken the sets here. The set that we've
Means,
defined was
of which two sets we do we need to take the intersection?
X, you need X. What are the two conditions on X? First is X such that X, you do understand this form, right?
Yes, yes. The
This is
form
X such that X is in the domain of G. So X such that X is in the domain of G, which is this condition. And then you want these two conditions to be satisfied simultaneously, right? And then X such that Gx is in the domain of F. This is the intersection that I was talking about. Is this clear now?
Okay.
Okay, so we're moving on to the next question. Messed up. And then we're moving to the fourth question, and I want you to give it a try. Try it and drop the answers in the chat box.
Ma'am, again, the alpha t is the growth rate or the population at time t, alpha t. Just in the previous question. Means if alpha t is the growth rate, then it is
Yeah, I'm
difficult.
just checking. Wait.
Means if alpha t is the growth rate, then we have to integrate. Otherwise, we can put in the value. I think alpha t should be the population at any time only because alpha naught
It
is the
is the
initial population.
population. It is the population only.
Ma'am, alpha is population.
But wait, this isn't the definition of alpha t, it's the definition of D. The percentage thing is the growth rate that you were talking about is it's D. They've defined D to be that. They've not defined alpha t to be that. I don't think there's a problem with the question.
Ma'am, D should be taken as 4% or 20% because like for 5 years it will be 20%, right?
It's 4. 4 is the growth rate. Every year it's compounding. So this is the formula for the compounding, right? So it's 4 here. That's how compounding works. We don't have much time left, and can we just move on to the answer of this? Can
Could you please confirm the answer I've sent on chat?
I'll just do it here. Starting with the solution of this now. So we've been given an equation alpha t. Alpha naught 1 plus d by 100 to the power t, right? So the population growth in an area can be predicted according to the equation this. So this is the population actually at time t, where d is the percentage growth rate of population per year and t is the time since the initial population count A naught was taken. So again, we're taking alpha naught when alpha naught is nothing but alpha when t is 0. But yeah, is the time since the initial population count alpha naught was taken. So in 2015, the population of Adyar was 30,000. So in 2015, we had the population equal to 30,000. And the population growth rate is, so your D is the growth rate. It's given to be 4. So just 4 because 100's already there. So then what will be the approximate population of Adyar in 2020? So you want it in 2020. And this is the initial population, right? Let's just consider this to be the initial population, which would give us alpha naught equals 30,000. But then you will have to consider 2015 when t is equal to 0. and you have been given the hint as well. So you can just take 2015 corresponding to t equals to 0, and which would give you t equals to 5 when it's 2020. T equals to 5 when it's 2020, right?
You should
Given here. You've been given the hint. Yes, someone was saying something. Okay. But in 2020, it's t to the power 5, and you have to calculate alpha t when t is equals to 5. So let's just substitute 5 here. So alpha 5 is equal to alpha naught. 1 plus, we know d is 400, and t is 5. That's all. And alpha naught is given to be 30,000. So this is 30,000. 104 by 100, which is 1.04 to the power 5. So again, it's not feasible to calculate this thing manually. You can just use a calculator, and it will give you the approximate value. So the approximate value is it's about
56,000.
36500. Yes, this is the approximate value. This is the solution. It's not the same, it's approximated. This was a pretty easy question. You guys need time to review this, and shall we move on to the next one?
Ma'am, can you please display the question once? I want to take the screenshot of the question.
Yep, sure. Yeah.
Okay, ma'am.
Excuse me, ma'am.
Yes.
From that 104 to the power 5 means 1.04 to the power 5, I had used binomial theorem, that approximation, and answer is coming around 36,000. Means not 500 is not coming.
You can just use the calculator.
That means without the calculator means I had used the binomial approximation, means 1 plus nx, that approximation. So
You must have made a mistake then. Plus, it's pretty lengthy. It's not advisable to calculate this thing manually when you have been allowed to use a calculator. There's no point.
Excuse me, ma'am.
Yes.
Ma'am, I have a different doubt, not related to this question.
Okay, is it related to any of the questions that we've discussed so far?
No, ma'am.
Okay, so if there's just one question left, we'll do that one, and then we can discuss it out. Is that all right?
Okay, miss. Okay, ma'am.
Oh.
Okay.
So this is the last question. Give it a try, and as usual, drop your answers in the chat box. Okay, let's just start with the solution of the question. So we've been given fx equals to x squared.
PDF after the session.
Sorry.
Will we get this PDF after the session?
Oh, yep. You can get this PDF after the session.
Still, where can we get? Because in some previous session, I was not able to find the live class PDF. They told that they will give, but I could not find. Could you be still? Where can we find?
I mean, I'm not sure about this. I'll just let you know in the next class, and I'll ask whoever handles this to share this. Okay, so this is the question, and it's though its natural domain is R, but we're not taking that. Instead, we're taking 0 to infinity, and you will get to know in a while why we're not taking the natural domain of this function right now for this question. And then we have to choose the points where your function fx and f inverse of x intersect each other. Intersect means a common point that lies on both of these, on the graph of both of these functions, right? So there are two ways to do this question. So your first method is you can just, so we know that the point of intersection of 2 points is, if we've been given fx and gx, and they intersect when we equate these two, right? So we can just equate these two, fx and f inverse of x. For that, we need to find f inverse of x, and there's a way to find f inverse of x. So if you've been given fx equals to x square, you can just put y equals to x square, solve for x, which will give you root y. And it's actually, when you solve for x, you get a plus minus y. But we're not taking two values of, okay, we're not taking two values of x here. We don't want to have two values. We'll just come to it later, why we're not doing that. Why we're not putting a plus minus sign here. This is y, and just replace the x with a y and y with an x. So you'll get this as the function. The problem here is, this is how you calculate the inverse. This is f inverse of x. And why we're not putting a plus minus sign here and here is because if you'll have a plus minus sign, then it's no more a function. So for this to be a function, and for every value in domain to have a unique value in the codomain, we would just take the plus, the positive side of it. So this is your f inverse of x. And then we'll just equate these two, x square and root x. And to make it easier, we'll just square on both sides. This is what we get. And please note that all the solutions of this equation are also a solution of this equation, but all the solutions of this equation are not a solution of this equation. So you have to be mindful of the solutions that you get here. You'll have to put it here and check if they satisfy this equation or not. If they do satisfy this equation, then only every solution of this equation, let's just call this 1 and let's just call this 2. The solution of 1 implies solution of 2, and not conversely. So the converse of this is not true. So first we'll find the solutions of this, and then we'll see if there are the solutions of this as well. But we 100% know that every solution of this is also a solution of this. So the solutions of this are going to be a part of the solution of this. It's in the same set, right? Let's just solve this equation. This is x to the power 4 minus x equals 0. This is x cubed minus 1 equals 0. Further factorizing it, we get x minus 1 and x square plus y square plus xy. No, we just put y equals 1 here. Right. Plus x equals 0. So this gives us x equal to 0, x equals to 1, and this you can check has no real root. This does not have a real root. You can check it using the quadratic formula, which will give you minus 1 plus minus 1 minus 4. So the discriminant is negative, and this is a complex number, so the roots are not real. So these are the real roots. And so we have to check if they satisfy the first equation or not, which is x square equals to root x. And they do satisfy, both of the values of x do satisfy this equation. That's why x equals to 0 and x equals to 1 are the solutions, right? And then we just find the corresponding value to y in putting x in one of these two equations. Either you put it here or you put it in the inverse, right? So this gives you y equals to 0 and x equals to y equals to 1 respectively for both of these. So it's 0, 0 and 1, 1. Also, what you were discussing this, right? Why the change the domain. So note that the function here that you have, so when you have f of x equals x square, and then you try to find the inverse of it, the domain of f is going to be the range of this function is actually for the inverse to be defined, you would want this function to be 1, 1, right? And this function is not 1, 1. Its graph looks like this. It's not 1, 1, obviously. So we're just eliminating this part. We don't want this part to be in the domain so that this function becomes 1, 1. Now this function, when you take x to be in 0, infinity only, this becomes this. So the function becomes this, which is 1, 1 on its domain. You want the function to be 1, 1 on its domain. So this is because it's 1, 1 on 0 to infinity only. That's why we've defined the domain to be this instead of the whole real line, because we're dealing with the inverse of this function. And for that, we want the function to be 1, 1. And there's one more way to do this question, which is using the graphical method. So this is the graph of, as we've seen, this is the graph of y equals x square for 0 to infinity only, but just considering this domain, not considering the other side. And the other one, y is equals to root x, looks like, let's just make a clear diagram. This, and then y is equals to root x looks like this. Both of which are parabolas, different axes of symmetry, right? And these are the point of intersections. And we do know that when a point is, let's just say, yx, not yx, it's a state. When we take xy to be on the graph of, okay, let's just make y is equals to x first. This line is y is equals to x. What we're trying to say here is, claim here is actually, we're claiming this, that the point of intersection of these two graphs, in fact, the point of intersection of f, we'll write this fact properly. Point of intersection of f and f inverse lies on y is equals to x line. That's where the point of intersection of two functions that are inverses of each other lie, right? So, and why does that happen? You can just
Is
see
it
from here.
true
So,
for every f and f inverse?
yes, it's true for every f and f inverse. The point of intersection of f and f inverse lie on y is equals to x. So you must be familiar with this fact at least, that if xy lies on f, this happens if and only if your yx lies on f inverse. This is where it comes from. This comes from here. And why is this so? If xy is on f, that means your fx equals y. So you have to check that yx should be on f inverse. You want f inverse of y equals x. And we know that y is equals to fx, which would give you f inverse of fx, which is x. That means the statement is actually true, right? Let's just write in a proper sequence. Fx equals y, and then we have our to show is that your f inverse of y. We want to show that your point yx lies on f inverse. So we want to show this, right? This is to show. And this is, where does this come from? You have fx equals to y, or let's just plug in the values only. Let's just substitute y from here. Let's just call this equation.
And this is turning out to be method 1 only.
Sorry?
This is ultimately leading to method 1 only. That
No, it's not leading to method 1. In method 1, you've taken this, right? You've solved this equation. This is what you've solved. Here you will just find the intersection of any of this, like either x square and x. So all I'm trying to explain here is that instead of equating these two fx's, x square and root x, instead of equating these two and then finding the value of x, you can just equate these two. Y is equals to x square and x, and then solve it. So if in case your function is very complicated and you don't want to find the intersection of these two, just find the intersection with y is equals to x. That's how it's different. Okay. Do you want me to do the proof of this, or can we just skip it?
understood.
Okay. So we need to show this. We'll just substitute the value of y from here, which is f. Use double star in above equation, which gives you f inverse of fx equals to x. This equation, if you put f inverse, let's just do this. F inverse of y equals this, and this is this. It turns out to be x only, which means that this is true, right? This just proves our claim. This was our claim, and we proved it here. That's all. And the converse part is done in a similar manner.
Please
It's
show
just
the
the
question
same.
and I could copy the question actually. It will be revision.
Sure, let me just get done with the solution first. So instead of just taking the intersection of f and f inverse, you can take the intersection of f and this. In case you've been given a complicated function, you've been given two complicated functions f and f inverse, you can just equate one of them, whichever seems easier to you, to x, and then solve for x. That would be the point of intersection of both f and f inverse. This is x square minus x, which gives you the same thing, x equals to 0 and 1. And
No,
with
so
this,
it's
we're
true
done with
for
this
every
question.
function.
Yes, it's true for every function. That's why we were doing the proof. So here's the question.
Thank you.
Okay. Is this clear to everyone? Can we just move on to doubts now?
Yes, ma'am.
Okay. You can just put your doubts in the chat box, or if it's too difficult to explain there, you can just unmute yourself. Yes, Krish, you can just ask what you want to.
Ma'am, so suppose there's a greatest integer function. Now,
Okay.
is it a increasing function or is it not?
Okay, so the greatest integer function is it's this, right?
Is the step graph?
Yeah. So it's basically how you define it is from 0, if you take any value from 0 to 1, you just take the greatest integer till that point, which will be, if you take something between 0 and 1, you'll get 0. So if you take something, you'll take y from 0 to 1, you'll get x at just right here. So this is it. And at 0, it's 0. This point is not included. It's included here. And then this point is again not included, included on the next step. Here. This one's included. Yes. So what was your question?
Is this an increasing function?
Depends on how you define an increasing function. So if you define it as if y is, or if you define it in this manner.
In the notes, it's given if x1 is less than or equal to x2 and f of x1 is less than or equal to fx2, then it is an increasing function.
Is this given in the notes?
Yes, this is given in the notes and this is taught in the lectures as well.
Okay, so then it is an increasing function.
Okay, ma'am.
Do you want me to explain, or
No, actually,
is it okay?
what I knew is that this is actually called a monotonous increasing function.
Yeah, that's how books define terms differently. That's not an issue. Some books call it strictly increasing. Some books just call strictly increasing functions and increasing functions. The other books,
Suppose let's take a value 0.7 and 0.9.
okay,
Both of them are having the same effect, same what do we say, result. So how is it increasing then?
because it satisfies this condition. That's why. If you take 0.7, which is strictly greater, then this means it could be greater or it could be equal. That's what this sign means, right? So this is it. And this does imply
Now both of them will be 1.
both of them
Sorry,
give
0.
0, right? 0 and 0 is equal to 0. So it's satisfying this condition. No, what's the issue?
Okay, ma'am.
Okay,
Thank you so much, ma'am.
you're very welcome. Any other doubts? Do we have any other doubts?
No, ma'am.
If there are any doubts, I'll just wait for a minute or two. If there are any doubts, you can just ask. Otherwise, we'll conclude the session.
Ma'am, I was late. Can you please go over question number 1 again?
Question number 1 is extremely simple. I think you'd be able to do it if you give it a try. Here it is. This is question 1.
Ma'am, can you give us some tips on how to prepare for the quiz 1?
Quiz 1, there are questions, right? There are questions to practice, and then there are lectures. Just go through them. If you're able to solve the graded assignments and everything, I think you should be good with the quiz as well.
It's okay, ma'am, to solve.
Are there any other doubts?
No, ma'am.
Okay, so we'll conclude this session. I think we can just end the session here. And thank you.
Thank you, ma'am. Good night.
Good night, everybody. Bye.